climate change. It is a serious issue and it has devastated our world over the decades. Though climate change has many aspects, causes and effects, one especially powerful aspect of climate change is the El Nino effect. The El Nino is a very peculiar phenomenon. Scientists are still unsure of its exact causes, but we do know what happens during an El Nino and what the effects are, which is what we will be exploring in more detail in this video.
The El Nino is a strange seasonal phenomenon. The term El Nino refers to the warming of the ocean's surface in either the central or eastern tropical Pacific Ocean. The strongest temperature anomalies are usually located off the coast of South America. This warming causes a shift in the atmospheric circulation, with rainfall becoming reduced over Indonesia and Australia, while rainfall in tropical cyclone formation increases over the tropical Pacific Ocean. The low-level surface trade winds, which normally blow from east to west along the equator, either weaken or start blowing from the other direction. Historically, El Nino events are thought to have been occurring for thousands of years. Scientists have found the chemical signatures in warmer sea surface temperatures and increased rainfall caused by El Nino in coral specimens that are almost 13,000 years old.
Developing countries dependent on agriculture and fishing, particularly those bordering the Pacific Ocean, are the most affected. It is thought that there have been at least 30 El Nino events since 1900, with the 1982-83, 1997-98, and 2014-16 events among the strongest on record. The El Nino has many diverse effects on our world. As warm water spreads from the West Pacific and the Indian Ocean to the East Pacific, it takes the rain with it, causing extensive drought in the Western Pacific and rainfall in the normally dry Eastern Pacific. Singapore experienced the driest February in 2014 since records began in 1869, with only 6.3 millimeters of rain falling in the month, and temperatures hitting as high as 35 degrees Celsius on the 26th of February. The years 1968 and 2005 had the next driest Februaries, when 8.4 millimeters of rain fell.
During El Nino events, the shift in rainfall away from the Western Pacific can mean that rainfall across Australia is reduced. Over the southern part of the continent, warmer than average temperatures can be recorded as weather systems are more mobile and fewer blocking areas of high pressure occur. The onset of the Indo-Australian monsoon in tropical Australia is usually delayed by 2 to 6 weeks, which as a consequence can mean that rainfall is reduced over the northern tropics. The risk of significant bushfires in southeastern Australia is higher following an El Nino event, especially when combined with a positive Indian Ocean dipole. During an El Nino event, New Zealand tends to experience stronger or more frequent westerly winds during the summer, which can lead to elevated risk of drier than normal conditions along the east coast. Because El Nino's warm pool feeds thunderstorms above, it creates increased rainfall across the East Central and Eastern Pacific Ocean, including several portions of South American west coast. The effects of El Nino in South America are direct and stronger than in North America. The El Nino is associated with warm and very wet weather months in April to October along the coasts of northern Peru and Ecuador, causing major flooding wherever the event is strong or extreme. The effects during months of February, March, and April may become critical. Along the west coast of South America, El Nino reduces the upwelling of cold, nutrient-rich water that sustains large fish population, which in turn sustain abundant seabirds, whose droppings support the fertilizer industry. The reduction of upwelling leads to the death of thousands of fish off the shore of Peru.
The local fishing industry along the affected coastline can suffer during long-lasting El Nino events. The world's largest fishery collapsed due to overfishing during the 1972 El Nino Peruvian anchoveta reduction. During the 1982-83 event, jack mackerel and anchoveta populations were reduced, while scallops increased in warmer water, but hake followed cooler water down the continental slope, while shrimp and sardines moved southward, so some catches decreased while others increased.